Good day to all. We would like to present our work, AVEST, a benchmark for visual object tracking in adverse visibility. This work was done in collaboration between MBZ UAI and ETH Zurich University. Recent years have witnessed a significant progress in the field of visual tracking, with a plethora of trackers introduced in the literature. However, these trackers have robust performance in normal tracking settings only. While tracking datasets have greatly benefited the tracking research, they no longer pose the same difficulty as before to the current state-of-art trackers due to the rapid progress in the field. In addition, diverse scenarios such as adverse visibility due to weather conditions, camouflage and illumination effects are underrepresented in these datasets. In this work, we propose AVEST, a benchmark for visual object tracking in diverse scenarios with adverse visibility. AVEST better accommodates the difficult conditions encountered in the real-world applications. Our dataset comprises of 120 challenging sequences spanning 18 diverse scenarios and 42 object categories. The proposed AVEST is densely annotated with accurate bounding boxes following a thorough quality control. We evaluate 17 popular trackers on AVEST, including the most recent state-of-art methods. We further analyze the performance of different trackers across attributes, which can provide valuable insights for specific applications. Here we display the distribution of image sequences in our dataset with respect to the scenarios and attributes in the proposed AVEST benchmark. Our dataset comprises of 120 challenging sequences with diverse scenarios. These scenarios cover adverse weather conditions including heavy rain, dense fog and hurricane, obstruction effects such as splashing water, fire, sun glare and smoke, adverse imaging effects, target effects such as fast motion, small target along with camouflage. This figure shows sample video frames from our dataset corresponding to different attributes. As discussed earlier, AVEST aims to provide a benchmark for evaluating visual trackers under diverse scenarios. With this objective, we first collected a large pool of around 400 videos from YouTube covering the 18 diverse scenarios with adverse visibility. We filtered out unrelated contents in each video and retained the relevant clip for tracking. We then annotated the target object in the first frame of each streamed video. Next, we qualitatively analyzed two recent representative trackers, Keep Track and Stark, on these image sequences. We selected a set of 120 sequences which are highly challenging for both these representative trackers. AVEST dataset comprises 120 challenging videos from YouTube under the Creative Commons license. All these 120 videos are categorized into 42 object classes and belong to at least one of the diverse scenarios with a total of 80K annotated video frames. The frame rates of these videos ranges from 24 to 30 frames per second and the average sequence length is 664 frames. The shortest sequence in our dataset has 99 frames, while the longest one has 3113 frames. After data collection, the next step is to obtain high-quality annotations for all sequences to ensure an accurate benchmarking of visual trackers. In the annotation part, a custom tool was prepared for annotating the video sequences. AVEST comprises different flags where a frame can be labeled with full occlusion, partial occlusion, out of view, and adverse visibility. In case of adverse scenarios where the target object suffers from extreme visibility issues as in dense fog and low light, the annotation process becomes very challenging. Therefore, we employ standard image enhancement techniques including contrast limited adaptive histogram equalization and gamma correction to distinguish the boundary of the target and improve the annotation quality. Furthermore, we also improve the annotation quality by making separate teams for the process of labeling and validation. Labeling team manually annotates and cross-checks the annotated video samples. Afterwards, the validation team verifies the quality of annotated videos and points out the possible mistakes. Figure at the left displays example frames where the initial annotations are fine-tuned, leading to improved annotation quality. We evaluated 17 trackers that belongs to different paradigms like Siamese, discriminative classifiers and transformers on Avest. Following Lazard, we evaluated the tracking performance using one-pass evaluation, assessing the success score of different tracking methods. Success score is calculated as the intersection of a union of the ground truth bounding box and tracking result. The area under curve, which ranges from 0 to 1, is used to rank the trackers. We report the results of different trackers in terms of AUC score, OP50 and OP75 on Avest. Mix Format 22K, which employs an ImageNet 22K pre-trained backbone, achieves an AUC score of only 56%, demonstrating the challenging nature of Avest. Among existing trackers, Stark ST50 and Tom50 achieve comparable AUC scores. Here, we show individual frames of some representative sequences and visualize the ground truth annotations and predicted bounding boxes of 4 trackers with different colors. These trackers belong to different tracking paradigms. Keep Track, which is a discriminative classifier based tracker, Siam RPN++, which is a Siamese tracker, Stark ST101 and Mexforma L22K, which is transformer based. To conclude, this work is about introducing a new benchmark, Avest, for visual tracking in diverse scenarios with adverse visibility. Avest comprises of 120 challenging sequences grouped into 5 attributes, covering 18 diverse scenarios with 42 classes. Avest, apart from tracking, can be used for several computer vision tasks like video object detection, scene understanding, image or video restoration. Thank you.